Hello everyone, welcome to my channel. I'm Vivian. Here today we will continue our topics about probabilities. In our last video, we already talked about what is a sample space in probabilities. So now in this video, I want to talk about what is an event. Event, in fact, this is related to our sample space. So if you want, you can look at my previous video. I will have my link here. So event, in fact, the definition of this, event is a subset of our sample space. So in sample space, there are many outcomes and it contains all the possible outcomes in the sample space. And then for an event, it means we will give some requirement. And then only the outcomes satisfies these requirements is the elements in our event. So event is still a site, but it have less or no more outcomes compared to our sample space. So here I want to give some examples for this part. So the first one is an example about if we want to flip a coin. So when we flip a coin, then what's the sample space we can have? So we can get a tail or we can get a head. So that means when we flip a coin, for our sample space, here are two possible outcomes. The first one is head, so I use H to denote it. And the second one, also the last one, is get a tail. So for our sample space, this means we have two outcomes, H and T. Then what is an event? Event can be defined any of them. So here for this one, my event I can interest in about I get a tail. So here if the requirement is I get a head, let's see, get a head. Then what this means, here we only have one outcome, only the head satisfies this requirement. So then our event is E equal H. This is the event satisfies this requirement, get a head. So here this is an example of this event. And then how about we have one more example. So this example is 3 signals. So what this experience means, so now we want to send 3 signals. And then what's the possible outcome for each of the signals? So it means we can receive it or we didn't receive it. So for this one, for each of these signals, we have two possible outcomes, receive or not. But if we have 3 signals by sequence, then what this means? This means, of course, for the first signal, we have receive as R or not receive as N. This is for our first signal. But then if we think about what is the second one, then for the second one, they also have R as receive or N as not receive. But this one, we have this for no matter for the first signal we receive it or not. So that's why here for the second level, in each case we will have R and N for these two cases based on we receive the first one or not. And similarly for the third level, about the third signal, for any of the case we also have R or N for the third level. So here you can see now this looks like a upside down tree, right? We have each of them have 2 branches, and these 2 branches have R and N. So now this is a tree graph about this experiment. Now let's look at what is the all possible outcomes for the sample space. So here for this one, if now let us look at the first about all go to left in this graph. So this means we look at R and go to left and then go to left. So in this blue circle, you can see we will have received first one and second one and then third one. So this is one possible outcome. We receive all of the three signals. So we can denote this outcome as R, R, R. And then how about the others? So now if we look at receive the first one and then also go left, but instead of go left on the third level, we go right. So then we will have this orange circle. So it's receive the first one, second one, but now receive the third one. So in this case, we will have R, N, R, R, N. So this is our second possible outcomes. And then we can do this and to run all of them. So let me choose a green color. So now we still receive the first one, but now we didn't receive the second one, and then turn left before the third level. So in this green circle, you can see we will receive the first one, not receive the second one, but receive the third one. So we will do all of this to this three-level tree graph. Then the next one can be R, N, N, and the fifth one is now receive first, receive the second signal, receive the third signal. So we can do this for all of them. And in total, we have 8 possible outcomes. The last one is N, N, N. So we didn't receive any signal. So this is one example about this simple sample space. And then what is an event? So event is some requirement, right? So here, what my requirement? My requirement is if we only receive one signal. So if I only receive one signal, what is this event? So by our donation of the sample space and all outcomes, if we only receive one signal, it means we only have one R in our outcomes. So in this one, that means the first RRR is now satisfied. And same for the second one and third one. But if we look at the fourth one, this is RNN. So I underline this, double underline this by red color. So you can see this is satisfies our requirement. And then the next one, outcomes, only have one R is NRN. And the last one is NNR. So these three outcomes satisfies our requirement. Only receive one outcomes. So this is the elements in our events. So we denote this by E. So now this E only have 3 items. Is RNN, only receive the first one, RNRN, only receive the second one, and NNR, only receive the third one. So this is our outcomes, satisfies this requirement, and this is a result for our event. So now this was a definition and 2 examples about event. So if you like this videos, please like my video, subscribe my channels, and we will continue in our next video for probabilities.